Okay, guys, I have given you 7.21. It's quite a thick packet. There's a reason for that. I think these problems are really important to give you a real, just kind of a better understanding of really what this unit circle is. I know we jump into the unit circle and we kind of do problems where we have these perfect angles around the unit circle, but we kind of miss all those angles in between and really understanding what happens. And so we lose some of the basic understanding of what trigonometry is, right? When we do all this stuff. So what I want to do is first show you how this actually works, how we can actually find the sine of any angle using this unit circle, right? Because we know and we've established that whatever this angle is, whatever some angle that we draw, okay? We draw some angle. I don't know why I still have trouble. We draw some angle, and we always start with our initial side here. We just draw some angle here, okay? Wherever this meets, and as our x and y value, we know the x value will be the what? What will the x value be, and what will the y value be? So this angle, whatever that angle is, right? Who knows what it is? It could be 32 degrees. It could be 28, whatever. I don't know what it is. But the cosine of that angle will be the x value, right? And the sine will be the y value. Okay, we've talked about that before. Okay, so let me give you an example. Let me erase this. What if I were to draw a 60-degree angle? Okay, we know something about the 60-degree angle. Right? I'm going to draw a 60-degree angle again at the origin. Here's my initial side, right? And I'm going to draw a 60-degree angle. Now, I got a handy tool here where I can actually use this protractor and find where we're at 60 degrees. Okay, I'm going to draw a 60-degree angle approximately right there. So hard to make it perfect. So say I want to draw this 60-degree angle right there. Again, I'm going to make a line. And here's my 60-degree angle, right? So let me move that over for now. There's my 60-degree angle. It cuts the unit circle. It's 60 degrees here, right? We just measured it. Gosh. Just measured this angle is 60 degrees. And it cuts through here at an x value. Look at that. Cuts through here with an x value. Right here. Look at where that x value is. 0.5. Okay. Now, why is that x value 0.5? Well, look at that triangle. What kind of triangle is that, right? What kind of triangle do we have here? This triangle right here. That's not what I want, is it? How do I go back? This triangle right here is this triangle right here is what kind of triangle? That's a 30-60 right triangle, and we know this small side of the 30-60 right triangle is 0.5. Okay, and well, we knew that, right? I had you guys memorize the 60-degree angle, right? If this is the 30. This is half of the hypotenuse. This side is half of the hypotenuse. If we flip it around 60 degrees, this is half of the hypotenuse. So the cosine is a half. Now, of course, the sine is square root of 3 over 2. Now, what's the other good part of this, right? Square root of 3 over 2 should be the y value. So if I just follow this over, if I draw this straight across, it's not being nice to me, is it? If if I draw this straight across, that should be meeting my y-axis somewhere around square root of 3 over 2. Now, pull out your calculator and see what square root of 3 over 2 actually is. Square root of 3, make sure you close the parentheses on the square root of 3 if it gave you parentheses, right? Square root of 3, because you got to divide that by 2. You got to make sure you close the parentheses, otherwise, boy, my calculator is not working very well. Square root of 3, I've got to move to the right. I've got a different calculator here. Divide by 2, 0.866. Well, that looks about right. I mean, you can see this side here actually. This line that I made was a little bit too high, right? I should have been closer to like there. And you can see it's a little bit above 0.85, right? 0.866. So you can imagine that's a pretty good approximation we can get for the sine just by drawing a line straight across and approximating where that is. You might have approximated it as 0.85, 0.87. Okay, so 0.86 is a pretty good approximation for the y value, which is the sine of 60 degrees, right? Okay, now we're going to use this unit circle. We're going to come back to it many times while we do these problems, okay? So let me erase this. Oh, gosh, I don't know why. Erase all this. We're going to go down here, and we're going to do one of these problems. I'm going to hide the ruler. Now, for these problems, we're kind of going backwards. I'm going to find all the places, right, where the sine is equal to 0.3. And we're going to do it in different ways. So sine of 0.3 actually has two different places, right, where sine is equal to 0.3. So let's go back up here. And on our unit circle, let's find where the sine is 0.3. Now think about it. What did I tell you is the x, and what did I tell you is the y values on the unit circle? Right? The sine is the y value on the unit circle, where an angle touches the unit circle. So again, if we start with our initial side here, okay, and we draw an angle, and it has a sine of 0.3. That means what? That means the y value is 0.3. That means this angle, wherever it is, has to cut through and have a y value of 0.3, right? So I'm going to follow 0.3 over and see where it crosses the unit circle. And it also doesn't just cross there, it crosses over here. Y value of 0.3 is also over there. So I've got two angles defined, right? I've got this angle, right there. Whatever this angle is one of the angles that gives me a sine of 0.3. And then I'm going to use blue for my other one. Okay, again, my initial side is here. Oh, I don't like that at all. Sorry. My initial side is also here, right? And it rotates now all the way over here so that I meet this point, right, from the origin, reaching all the way over there, okay? Didn't draw it straight for me. So from here, keep some of these things I'm just getting used to. From here all the way to here. And again, sorry, I got to keep going back to my line tool. So that's my other angle, right? This angle right here from the x, positive x direction, rotate it around, whatever that angle is. It's a pretty big angle, right? There's only a little bit less than 180 there, okay? Now, I want to actually find the measure of that angle, and I'm trying to find how much this angle is so I can go ahead and use my ruler, right? And in class, we're going to use a protractor to actually measure these angles. Okay, so here's 0, right? Here's 0. And I'm going to rotate it and get to measure this angle. so that it crosses right there. Sorry guys, on the last video I was interrupted. There's only a certain amount of time I get on the screen capture video thing for the free version. So anyway, we've got an angle. You'll notice here that this angle crosses the unit circle is at about an 18-degree angle, okay? So one of the angles is going to be 18. If I rotate it all the way around, you could guess probably what that is, right? It's 18 degrees. Now this protractor measures from the horizontal, and it's also 18 degrees, right? But it's 18 from here up this way, so it's 180 minus 18. So we're going to go hide this ruler. We've got 18 degrees, and we've got 180 minus 18, which is going to be 162. Okay, those two angles have a sine of 0.3. Okay, so let's go over here. Two solutions of the quadrants and the angles. Why do we know quadrants 1 and 2 have a sine of 0.3? Now remember when we did our all students take calculus, right? That tells you which ones are positive. All of them are positive here. All of them are, only the sine is positive there. So the sine is positive above the y-axis, right? Above the x-axis. It should make sense that everywhere above the x-axis, sine is positive. So there has to be two places where sine is positive, a positive value of the same number, right? So we're going to go ahead and approximate where this is on this little mini unit circle. Right here, this is one angle. And right here, this is our, I don't know why we're doing, makes shapes when I don't want it to make a shape. Right? Let's cancel that into shape. We got another angle over here, okay, which is this angle, okay, and we know they're in quadrants 1 and 2. We drew a quick sketch of our angles on our mini unit circle. We used our protractor and the large unit circle back from the first page to find the first quadrant solution. What was that? That was approximately 18 degrees, right? And we used the first quadrant answer in logic to find the second quadrant, which is 180 minus 18, right? So that was 162. Okay, work, I guess I could have done the work here. 180 minus 18 equals 162. Okay. Now, for part E, we're going to go to the graph of sine. Now, we're dealing with two different things here, right? We're dealing with the unit circle, which is basically the x and y values as we go around this circle, right? Any point we choose on the circle, the x and y coordinates will give us the sine and cosine, the cosine for the x and sine for the y, of any angle around this circle. But when we actually draw the graph of sine, and if I do it in degrees, and I know we've been normally graphing this in radians, but we're doing it in degrees from 0 to 360. It's the same as 0 to 2 pi, right? Comes back here at pi, or 180 degrees. I can look at the graph and find where the sine is equal to 0.3. Where is the sine equal to 0.3? Now we're talking about the y value when the sine is the angle, the x is the angle, this is the angle. We're plugging into the function sine of x. So if we had an angle of x, we're trying to find the sine of the angle, y, the y value, not why, but the y value is the sine of the angle, which is x. Now, here's my x. See my angles here. These are my x values. So I'm plugging in 0 degrees, 20 degrees, 40 degrees, 60 degrees, etc., and I'm getting my graph of sine of x. Okay? The green graph is the graph of sine of x. What I want to do is find where this green graph, where this function is equal to 0.3. Now look, I've got this green graph here. Notice that from 0 to 180, you've got two places where the sine is going to be equal to 0.3. You got one right in here somewhere, right? Okay. You got one right in here somewhere, 0.3. right in there somewhere. And if you keep drawing 0.3 across, it's halfway between 0.2 and 0.4. You get one right there. Okay. Now we're going to follow that down and approximate where that is. Right. Let me draw a line from here down. And can you see that's approximately 18 degrees? And if I draw a line from here down, oops. If I draw a line from here down, you're going to see that is approximately 18 subtracted from 180, which is 162. Look at that. We're just using the graph, right? We didn't take out a calculator. We didn't do anything. What angle gives a sine of 0.3? Approximately 18 and approximately 162, right? Okay, so going back up here, again, using the sine graph, we're approximately 18 and 162, right? Now, it's not going to be perfect, right? We're approximating. They do look close to my answers from part A. I kind of knew what the answers were in part A, B, and C, right? C and D or whatever, whichever one had our answers. So we knew it was going to be approximately that, but you should be checking, right? If you got 28 here, then you did something wrong either on the graph or on the unit circle, right? Should be about the same. And this one was right before 20, so it was a pretty good approximation. Right? This is a little after 160, so it's 162 is a good approximation. Okay. Now, right? Now let's use our calculator. Okay. Be sure it's in degree mode. We're going to check our approximate answers we found by typing sine of our approximate answers. Okay. So we're going to type the sine of 18 degrees. Okay. Sine of 18 degrees in our calculator. Go to our calculator. Sine of 18 degrees, 0.309. If I were to approximate that to the nearest hundredth, it'd be 0.31. If I approximate to the nearest tenth, it is 0.3. A pretty good approximation, right? Sine of 18 is about 0.3 if I were to round to the nearest tenth, for sure. Okay. What about the sine of 162? If I plug that in, okay, sine of 162 is also the same number, 0.309 something, right? So round to the nearest tenth, 0.3. Yes, we're getting approximately the same answer. Okay, saw this in geometry a long time ago, actually. Saw this, we've seen this recently. You can use your calculator to find approximate values of sine of x is equal to 0.3. By undoing the sine function, we look for the inverse sine of both sides, right? So if we were to solve sine of x equal to 0.3, I go really hard on you guys about this. Sine of x is equal to 0.3, and I solve for x. What do you have to do to both sides? You have to do inverse sine of sine of x and inverse sine of 0.3, right? Inverse sine of x gives us x on the left, and on the right we get inverse sine of 0.3. Again, in your calculator now, inverse sine of 0.3, and it's 17.45. See, now it's not a great result because we let me make sure I'm in degree mode. I'm in degree mode. I got 17.4 degrees, right? 17.45 degrees, right? If we round to the nearest tenth, that'd be 17.5 degrees. But it went around up to 18. It would round actually down to 17. So we were pretty close, right? We approximated it to be 18 degrees, and it was 17 and a half, okay? Or if we round down to 17, pretty good. If we round to the nearest 5 decimal places, it's 17.457 60 degrees. Okay. Now, notice our calculator only gives us the one angle, right? It only gives us one angle that is equal to 17.45 something. Okay. Now, we can do the same calculation. Okay, guys, I didn't know I got cut off again. Anyway, to finish this problem, to find the other angle, we can just subtract 180 from that angle, right? Because we know using logic, it has to be the supplement of that angle. And we are going to get 180 minus the answer, 162.5423, or 240 if we round, right? To 5 decimal places. So it's 162.54240 degrees. Okay, those are the two angles that give us a sine of 0.3. We were pretty close in our approximation on our graph. Okay, if we had some really huge unit circle and some really big protractor and ruler, we could probably get a lot closer to the 17.5, right? By having a better, but on this small screen, on this small paper, it's a little bit hard to be that precise. Okay, so I'm going to do one more question here, and this time we're going to do the sine of negative 0.3. Okay, so remember the sine of negative 0.3. Again, if we do, all students take calculus, which helps us remember where they are positive. All of them are positive here, so it's not going to be negative there. Sine is positive here, so it's not going to be negative there. This is where the tangent's the only one that's positive, and this is where the cosine is the only one that's positive. So the sine is negative below the x-axis, which should make sense, right? The sine is negative here because that's where you have to go on a negative y value, right below the x-axis. So remember, the sine is the y value. So now I'm going to try to find where the sine is 0.3. It's somewhere like there and somewhere like there, right? We've got some angle cutting through here. I didn't like that. Got some angle cutting through here, and we got some angle cutting through here. We're talking about this angle, right, all the way there, and we're talking about this angle all the way over there. Let me use a different color. That orange angle, and then we're talking about this multicolored angle. Okay, we need those two angles. Those are going to be our answers. Okay, so I approximated where I'm going to get negative 0.3 for my y value, right? This is about negative 0.3 for my y value, and it's going to touch my unit circle at those two places. Okay, now let's go back up to our big unit circle and see if this makes sense. Where is negative 0.3 on the y value? Remember, we're looking for the sine. The sine is the y value. And I've got a nice dotted line over here that meets it right here. And a nice dotted line that meets it right here. This is where sine is equal to negative 0.3. Okay. Now, we're gonna draw our line. Let me do it in green. Actually, let me erase this other stuff. Okay. Don't need it right now. And we're going to make a line, but we're going to do it with green from our origin, right? We always start here, right? And we're going to measure all the way to this point right here, right? So we got to draw a line where the terminal side goes right here. Okay? So I want to measure. That didn't become a straight line. I'm still learning how to do this. Sorry about that. Straight line from here to here. It's pretty precise, right? Okay, so there's the angle I want. That's the first angle I want. And really, we've got to measure, this is 180 plus this little part. You might be guessing what it is, right? So there's 0. If I measure this way, what do I get? Well, you see, we came up with 17.5 the other time. This protractor is not that precise because I'm getting, when I'm on that side, it's 17. When I'm on this side, it's 18. You guys see what's happening? If I'm just a little bit, yeah, it's looking closer to 17 this time, right? But again, if I go just on the other side, that's why that's 17.5 is a good approximation. But I'm going to write down 17 this time just for the hell of it, right? Got 17 degrees, but that's added to the 180, right? So now, and then, of course, this side, it's funny how the protractor is measuring, like this digital protractor is measuring the angle with the x-axis. I told you how important that was. That's the reference angle. And again, we got 17 this time. Okay. Now, it's the same angle. It should be about 18 or 17, which is why we're getting 17 on one and 18 on the other. We're approximating here, right? But I'm going to go here and see that this is 18 degrees here inside plus the 180, right? 180 plus 18 is approximately 198, right? 198 degrees. Well, it was 17 is what I found this time, right? I should not cheat. 17 degrees. And then if that's 17 degrees again, if this is 17 degrees, then what is this angle from here all the way around? Okay, it's almost a full circle. 360 minus the 17, right? So what is that one? 360 minus 17, 343. Okay, I could have used my workspace here. 360 minus 17, 343. I'm beginning to really like this tablet. I'm getting a little bit better at writing here. Sorry, it's a little tough at first. Okay, find the solutions using the sine graph. So now we're going to go back up. See where the sine is equal to negative 0.3 on the graph of sine. So remember what we did there. Now we're looking for where the sine is negative 0.3, right? Negative 0.3 is somewhere in there. Let me see if I can draw a straight line across at negative 0.3. That's not working. Now I forgot to make my line tool, right? See, it doesn't put it exactly where I want. When I do put it where I want, I'm not making a line. Sorry about this, guys. I'm making a line starting from here. Ugh, really don't like this, why it's doing that. Anyway, 0.3 is halfway in between here. Trying to see where it crosses that green line, right? It crosses the green line a little bit before 200. You guys see that? A little bit before 200. And this one is a little bit past 340, right? You guys see that? If I had to approximate, I would probably say it's, a couple degrees before 200. I'd probably say 198 for the x value, which is the angle that I'm plugging in the sine. This one is probably 342, right? Just approximating based on my graph. So we had 198 and 342. Again, these numbers should be close, and indeed they are, right? I was just approximating based on the graph. Are they close? Yeah, they're pretty close. And then you could do the rest. Sine of negative 0.3. I've only got so much time left on this video. I'd like to get this done. How do we get sine equal to negative 0.3? We do inverse sine of negative 0.3, and we get negative 17 degrees. Okay, I'm going to make another video because this one's about finished describing what's happening here. Okay, I want to finish that video up, guys. And I don't know why I'm having trouble finding. Gosh darn it. Sorry, I'm getting used to the Windows environment here. Okay, now we actually are looking for where the sine is equal to negative 0.3, where the sine of theta is equal to negative 0.3, right? Now, how do we do that on the calculator? Well, how do I do this algebraically? I have to do inverse sine of this angle, inverse sine of the sine on the left, and inverse sine of that value 0.3, negative 0.3 on the right. So I get theta equals the inverse sine of 0.3, and I get negative 17.45. Okay, let me just, negative 17, I'm going to write this to the nearest negative 17.4576, right? That's what my calculator is given to 5 decimal places. Now, as I've noted here, it's in the 4th quadrant, right? How do I get the angle that's in the 3rd quadrant? Well, also, this is not my actual answer that I want. This is the reference angle, and I've got to take the reference angle and subtract from 360, or take this and add it to 360. So if I take 360 plus the negative 17.45760, what do we get? Okay, so I'm going to add the negative 17 point something to 360, and I get 342 point something. Okay, so if I round that to 5 decimal place, 5 decimal place, 342.54239, which is 240, right? So that's my angle in the 4th quadrant. But this is really like my reference angle, right? This negative 17 number. I can use that number and add it to 180 or subtract it from 180, right? Depending on how you're looking at it. But basically, I need to add the 17.45760 to 180 to get my other answer, right? So I'm going to go back, get negative 17, and I'm going to take 180 minus that answer and get 197.45760 degrees. Okay, so notice our calculator actually gives us a negative answer because it's trying to give us the inverse sine values. We didn't really talk a lot about that, why the calculator is giving us a negative value, but you can see that if I were to go in the negative direction on the unit circle, which we've done before, this is negative 17 degrees here, right? We'd be at negative 17 degrees. So if you wanted to get at the answers from 0 to 360, we've got to take that 17-degree angle and subtract it from 360. Okay, that's what we did there. Now, that's enough for today on your notes and your homework. I hope you are seeing a little bit now about how the unit circle is related to these angles and the sine values, and also the graph. So in class, we're going to deal with cosine graph, but basically doing the same thing, except instead of looking for the y values of 0.3 or whatever, we're going to be looking for the x values. Okay, so you may want to try the first one at home, see how you do, and compare it to how we do in class. We're looking for where the cosine is equal to 0.8. I'm not going to grade this. I'm only going to look for the first 2 problems. Okay, we'll work on the cosine in class together.